Alright, this is Sam Heinzen, starting Group 8 in our Chapter 18 presentation, Create Review and Coordination Processes to Increase Quality of Our Current Work. So the goal of this chapter is to enable DevOps to reduce the risk of production changes before they are made. Now, traditionally, changes for development rely heavily on external team reviews, inspections, and approvals just prior to development. This is not effective because the external teams are too far removed to have informed decisions, and time required to get all approvals lengthen change lead times. The solution is to integrate review into daily processes. One of the ways to do this is to understand the 5-step control repository management system. And the 5 steps are to first create a branch, and this is done when you begin working on something new and it's descriptively named. The second step is to commit work to the branch, and this is done locally while the work is pushed to the server branch. The third step is to open a pull request for help and merging. So when you need feedback or when the code is ready to deploy, you want to make sure that other people have a chance to look at it. The fourth step is to merge the branch to master, and this is done after reviews and approvals are received and you've made the changes requested. Finally, the fifth and final step is to deploy master to production, and this is once merging has all completed, the engineer deploys to the master production branch. GitHub is the shining example of the 5-step management process. We've all used it, and it follows these 5 steps to a T. It has allowed them to reliably deliver features to market with high quality and security. Now, one of the things that the book does address is the dangers of change approval processes. And it opens with an example of the Knight Capital failure, which is a real-life financial crash. Hundreds of millions of dollars were lost, and it brought about a realization in DevOps. Low-trust command and control cultures do not benefit from tightened change control processes and testing, but actually suffer increased problems. And the factors to this are going to be explored in further slides, but this was their opening to how we can move from a low trust to a high trust culture.
Large quantities of regulations and implementation of systems that are overly controlling can lead to a number of problems such as long lead times, reduced strength and immediacy of feedback, addition of more friction to the development process, addition of steps and approvals, increased batch sizes, and reduction of the likelihood of successful production. When many teams are doing hundreds of independent deployments per day, there may be a risk of changes interfering with each other. To reduce the risk of this happening, a few things can be done. Chat rooms can be used to announce changes and help find collisions, changes can be deliberately scheduled, and representatives from each team can get together to do the above scheduling.
This is Alyssa Hundley, and my section is Enable Peer Review of Changes. In development, peer reviewed is called code review. It is also applicable to all environments and applications. The code review benefits are errors are found by having others scrutinize changes made, and cross-training, peer learning, and skill improvement also happens with code review. Review code must take place before committing to an environment with team-wide impact. So I want to make sure that the review is done when it's only affecting the environment, the small development environment the person is working in, and before it's going to affect everybody else on the team. And when we work in small batch sizes, we get better code reviews. And here are 2 quotes from the book that I liked. Randy Shoup said, "There's a nonlinear relationship between the size of the change and the potential risk of integrating that change. When you go from a 10-line code change to a 100-line code, the risk of something going wrong is more than 10 times higher," and so forth. And then this other quote is, "Ask a programmer to review 10 lines of code, he'll find 10 issues. Ask him to do 500 lines, and he'll say it looks good." So we want to make sure that we're doing small batch sizes, doing little bits of code at a time so that we're efficiently finding these errors when the reviews are happening, and so that the risks also go down of injecting a small batch into the environments is much, the risk of that is much smaller than doing a large batch. And these are the guidelines for code review. Everyone must have someone to review their changes before committing to trunk. Everyone should monitor the commit stream of their fellow team members so that potential conflicts can be identified and reviewed. Define which changes qualify as high risk and may require review from a designated subject matter expert. If someone submits a change that is too large to reason about easily, in other words, you can't understand its impact after reading through it a couple of times, or you need to ask a submitter for clarification, it should be split up into multiple smaller changes that can be understood at a glance. So this is something that we want to make sure that all of these guidelines are met before adding these changes to the rest of the code. And it's super important that somebody else is looking over them and they understand what you're doing and feel like it is good to go to avoid future problems. And it's not going to avoid all problems, but it can definitely limit them. Okay, so pair programming is when programmers work in pairs. Over-the-shoulder programming is when one developer looks over the author's shoulder as the latter works through the code. Email pass-around is a source code management system emails code to reviewers automatically after the code is checked in. And tool-assisted code review, authors and reviewers use specialized tools designed for peer code review or facilities provided by the source code repositories. I have worked in an environment where we have built apps and websites, and I have used pair programming, over the shoulder, and email pass around, not tool assisted code review. But I know for a fact that the three work really well, and it's not necessarily that you want to always do one or the other, but you want to implement all of them to be able to be the most efficient. And it just depends on the time and the instance on how you would want to review the changes or program together. The last section is examine potential dangers of manual testing. Manual testing is slower and more tedious than automated testing. When testing failures occur, we will typically do additional testing, which is it has the consequence of taking significantly longer to test, which results in less frequent deploys and larger deployment batch size. So basically, we have a test failure, and so we're going to do additional tests to see what's going on, and then things take even longer than they should, and then we're not deploying as frequently, and then we end up with a large deployment batch size. So that's something that we don't want to do, and peer review can help us avoid these issues, these testing failures. And when we increase our batch size, which is a result of additional testing, our change success rate goes down and incident accounts go up. And to avoid this, we want to perform testing in our daily work as part of a smooth, continuous production flow. So testing shouldn't be at the end of the week or the end of the month. It's a daily thing that happens to avoid these failures as much as possible.
So in conclusion, high trust is the way to go. Increasing the quality of changes and reducing the risk of poor deployment outcomes can be accomplished by the following high trust methods, not the low trust. So in a low trust structure, command and control approved processes are prevalent. There is micromanaging of development teams, and the code is manually tested. In a high trust environment and culture, they use the 5-step repository management system, coordinate and schedule changes, and peer review those changes. And again, by following the high trust culture, the quality and security will be increased. And obviously the reference is our lovely book, the DevOps Handbook.